Brightstorm has thousands of high-quality videos covering all major subjects. Please check out more at www.brightstorm.com.
If we want to calculate the area of any regular polygon, the first thing we need to do is to write it inscribed in a circle. And by doing that, we've created the ability to draw an apothem. Now, an apothem is a perpendicular segment from the center of the circumscribed circle to one of the sides of your polygon. Now, the reason why this is important is because if we want to calculate this hexagon, so again, this will apply to any regular polygon, what we're going to do is we're going to think, well, Mr. McCall, I have no idea how to calculate that area. But what I do know how to calculate is the area of a triangle. So if I divide this hexagon into congruent triangles, and they'll all be congruent because it's regular, then all I have to do is add up the area of my 6 triangles. So you could say the area of the hexagon is equal to 6 times the area of one of those triangles. But how do we calculate the area of one of those triangles? Well, if you recall, in order to calculate the area of a triangle, you need 2 things. You need the base and its corresponding height. So that's why we need the apothem, is the apothem is that corresponding height. So specifically for a polygon, we're going to call this A, and we're going to call that base S, where if we go back here, S is our side length. So notice that the sides will all be the same for a regular polygon. So the area of this triangle is going to be the apothem, which is the height. So I'm going to say 6 times the apothem, times the base, which is S, divided by 2. So the area of a hexagon is equal to 6 times the area of one of your triangles. But that's not very useful because this is only going to apply to a hexagon. So let's make this area formula for any type of polygon. So instead of writing 6, I'm going to write n for the number of sides. So I can write this as apothem times side length times the number of sides, all divided by 2. Now if we look at this, I see that I can simplify this a little bit more. Getting back to our regular polygon, the perimeter, capital P, of this polygon is going to be 1, 2, 3, 4, 5, 6s. If I had a pentagon, that would be 5s. So what I'm going to do is I'm going to say that the perimeter of any regular polygon is n times s. So I can substitute in for n times s, capital P, which is going to stand for perimeter. So there's going to be 2 ways to write your area formula. And I'm going to erase this to make it a little bit clearer here. So we're going to say the area of any regular polygon is equal to apothem times side length times the number of sides divided by 2. Or if we substitute in for n times s, it's going to be the apothem times the perimeter divided by 2. So you have 2 different formulas, both of which will calculate the area of any regular polygon. Divided by 2. I can't do this with you 2 laughing back there.
Work it, work it.
So if we had, no, that's not right, 3 coplanar points.
So have you ever gotten off an airplane?
That should be less than. Yeah. Dang.
Is it like 500 degrees in here or what?
All right, so when you're in chemistry class, you're going to be doing a lot of work. You're going to be starting over.
So as an example, we could consider like you've got a chain hanging from two fixed.